I'm going to talk about arc length and area of a sector. And before we get into those two ideas, we need to refresh our memory when it comes to the circumference of a circle, which is the distance or length around the edge of the circle. And the formula for circumference is either pi times diameter, or it's 2 times pi times the radius. And I just want to point out that this formula is the formula that's on your green reference paper for the OST. So I don't use pi times diameter very often. If we take a look at an example, it says find the circumference of the circle below. And what we need to notice on this one is that this is the radius. And the formula for circumference is 2 times pi times r. And we can fill it in. It says leave your answer in terms of pi. What we're filling in is we're filling in this value of the radius, which happens to be 11. And then our circumference is 2 times 11 is 22 and a pi. Notice that I multiplied the numbers together, the 2 and the 11, multiplied together, and then the pi, that's the leave your answers in terms of pi. We don't always have to leave our answer in terms of pi. As we get to example number 2, it says use the given circumference, find the radius, and then on part A it says we're going to leave it in terms of pi, although watch what happens. Once again, the formula for circumference is 2 times pi times r. And this time the value that we're given is we're given the circumference. It is 20 pi. And over here we have 2 times pi times r. And what we want to figure out is what does r equal? Well, it's 2 times pi times r. So the inverse operation of multiplying is dividing. I'm going to divide by 2 pi here. I'm going to divide by 2 pi here. And the nice part is pi divided by pi is 1. This cancels out. And then we can do 20 divided by 2 is 10. And that's going to give us our radius. In fact, I did the 2's canceled out, the pi's canceled out, and we get our radius of 10. Doesn't always work out quite as well. Over here on part B, it says that the circumference is 8. Again, our formula for circumference, which is provided to you on the reference sheet, is 2 times pi times r. And this time what we're given is we're given the fact that the circumference is 8. So we're putting this value in where it equals. But this one tells us that we're going to round to the nearest hundredth. So it's the same idea. It's 2 times pi times r. We want to know what r equals. We're going to divide by 2 pi here. I'm going to divide by 2 pi here. The 2 pi's cancel out. That's going to give us our r. But this is where we need our calculator or Desmos. As I pull up the calculator, it's 8 divided by, and notice where the 2 pi is, and I think I need to put parentheses in here, but it's going to be 2, there's a pi button on the calculator, if you are using your calculator, and it's on the caret button here, on this button right here, and what we need to do to use that is we're going to go second, and then the caret button. You could use your fraction button to get that. But then this is going to allow us to round to the nearest hundredth, which gives us 1.27. We're looking at the 3 to determine what to do to the 7. So it's going to be 1.27 because 3 is less than 5. Sometimes we don't need to know the entire circumference. We only want to know part of the distance around the circle. And let me say that again. We just want to know the length, the distance around part of a circle. And what we can do if we want to just find part of the circle's length is we can set up a proportion to solve it to help us find the length of the arc. So in this particular picture here, what we want to do is we want to find the length of AB. So it's like we're cutting this circle, and what we want to figure out is just what is the distance from there to there. And the way we do that is we take the arc length, which I usually call x, and we divide it by the circumference of the entire circle. And then we take the central angle measure. Remember, central angle has its vertex at the center of the circle. And we divide it by the entire degrees in the entire circle. This formula is not going to be provided to you. However, if you practice this enough, it will be in your mind already. But again, here's how it works. If we want to determine the length of the arc, and we're going to round our answer to the nearest hundredth, we want to find arc AB, and I'm going to call arc AB x. So it's going to be x divided by the circumference of the entire circle. So the circumference here is going to be 2 times pi times 3. And before I get going too much farther, I usually circle this word length just to remind me what we're going to be dealing with here. And then on the other side, once again, remember, it's the measure of the central angle, which is 80, given to us in our circle, divided by how many degrees in the entire circle, which is 360. So it's arc length divided by circumference equals central angle divided by 360. We can simplify that up a little bit. This is x divided by 6 pi. We multiplied 2 times 3 to get the 6, and equals 80 divided by 360. When we go back and look at the directions, it says round your answer to the nearest hundredth, and this is how I deal with that. To solve a proportion, we're going to cross multiply. We're going to multiply those two together, and we're going to multiply those two together. And when we multiply, we get x times 360, which is 360x. And over here, 6 pi times 80, well, 6 times 80 is 480 pi. Ultimately, what we're trying to do is we're trying to figure out, well, what is the length of arc AB, if I can get there. There it is, where that x is. So we're going to divide both sides by 360. And now, when we finish, we can type this in. And again, if you're using a calculator, it's going to be 480 pi, which is second and then the caret, divided by 360. And that's going to give us our value here. And then lastly, what we want to do is we want to round to the nearest hundredth. So we're looking at the second 8 to determine what to do to the first 8. And since the second 8 is 5 or higher, when we round to the nearest hundredth, we're going to get 4.19. If we want to get technical, the units are feet. Circumference is a singular, area is square, it's square units. But we're dealing with circumference right now. Let's try another one. And again, this one probably is going to require a little bit of practice to get the formula in our head. So when we look at letter B, same idea here. We want to determine the length of EF. And when we set this up, here's our arc. I'm going to call it X. And when we're finding the length, we're going to use circumference. And circumference is 2 times pi times the radius. In this case, our radius is 15. On the other side, we're going to take the measure of the central angle. Well, the measure of the central angle is 130. out of the entire circle, which is 360. And maybe you don't even need to simplify it. I am going to simplify it down one more step here. But we get x divided by 30 pi equals 130 divided by 360. Ultimately, what we're trying to do is we're trying to figure out what does x equal. So we'll cross multiply. And when we do, we get 360x, and I don't really need to do it, but 30 times 130 gives us 3,900. 30 times 130 is 3,900 pi. But we want to find x, and we want to round it to the nearest hundredth, which is 2 decimal spaces. So we'll divide both sides by 360. And then it's a matter of typing it in. 3,900 pi divided by 360 gives us that value here, and then we can round to the nearest hundredth. Again, when we're rounding to the nearest hundredth, we're looking at, in this case, the second 3 to determine what to do to the first 3. And that means it's going to be 34.03. Our units are inches. But the second 3 is less than 5, so that first 3 is going to remain the same. If that second 3 was 5 or higher, then we round up. So there is circumference and length. The other formula that we're fairly familiar with is area of a circle. And if you're not familiar with it, remember to look at your reference sheet. But the formula for the area of a circle is pi r squared. So when we come over here to find the area of the circle, we're going to leave it in terms of pi. Once again, the formula is pi times r squared, and we fill it in. Area is pi times 9 squared, because our radius is 9 in this particular picture, and that's pi times 81. And typically in math, we like to write the number first. So let's write area equals 81 pi. By the way, again, units for area is square units, so this would be centimeters squared. Especially important in science, if not in math. And once we know how to find the area, finding the area of a part of a circle, which is called a sector. So similar to finding arc length, we can use the area of a circle to find the area of a sector. And a sector is a piece of a circle. Just solve this. A piece of a circle. And you think of it like a piece of pizza or a piece of pie. The diagram shows an example of a sector. So, in this one here, the thing is, the sector is this entire part of the circle. I don't want to cover up everything, but it should be shaded all the way in. And depending on how good the copier is how good my shading looks. But to find the area of a sector, what we do is we take the area of the sector, which I'm going to call x, and we divide it by pi r squared this time. So what we're looking for, area of a sector, divided by the area of the entire circle, and then again we're going to do the central angle divided by the entire measure of the circle. So it's almost the same thing as finding the length of an arc. The difference is that we're doing pi r squared on this problem instead of 2 pi r. So that's why I circle when we get to when we get to an example here, it's why I circle what is the area or what is the length. And again, when we set this up, so you can see the shaded up here on my problem, even though you may or may not be able to see it on yours. The intention was it's that little piece of a pie that we're looking for. So we're going to call that x, and we're going to divide it by the area of the circle, which is pi times 16 squared. We're given the radius, and then it's going to be the measure of the central angle, which is 16. How about measure of central angle is 45 divided by how many degrees in the entire circle, which is 360. We can simplify this up just a teeny bit. 16 squared is 256 equals 45 over 360. And ultimately what we want to do is we want to figure out what does x equal. So we'll cross multiply. And we get 360x equals, and I wrote this one, 256 times 45. 256 times 45 gives us 11,520. Don't forget your pi. Because we want to round our answer to the nearest hundredth, so we're going to divide both sides by 360. And then it's a matter of typing it in, whether it's decimals, whether it's the calculator. 11,520 pi divided by 360 gives us this value right there. So what we end up with then is we end up with x equals 100.53. And again, area is measured in square units. Lastly, we have on this picture here, but our goal was still to figure out what is the area of the shaded region. And again, the shaded part shows up better on the screen here than maybe it shows up on your paper. But when we start this off, we're going to figure out, well, x, that's going to be our shaded area, part that we want to find, divided by the area of the entire circle, which is pi times r squared. In this case, it's 20 is our radius. And then it's the measure of the central angle, which is 150, divided by the entire degrees, and I don't really need the degrees on there, the entire degrees of a circle. And we can simplify that up a little bit. Maybe you have to do the next step, maybe you don't have to do the next step. But we get x divided by 400 pi equals 150 divided by 360. And now we're going to multiply. We're going to cross multiply, in fact, these two. We get 360x equals 400 times 150. 400 times 150 gives us 60,000. So it's 60,000 pi. And then we're going to divide both sides by 360. And when we type it in, 60,000 pi divided by 360. And we want to round to the nearest hundredth, which is 2 decimal spaces. So in this one, when we look real close at this, here we're looking at the 8. which means because 8 is 5 or higher, we're going to round that 9 up to a 0, which means that we're going to have to round that 5 as well. This actually ends up to be 523. 60. It's like rounding the 59 to 60.